Okay, in this fourth lecture, we're going to talk about property testing. So recall that in the previous lecture, we have seen some simple unit tests for this negative hour timed smart contract. And for these unit tests, we just came up with a bunch of values for the two kind of variables we have here. And we just kind of set here whether we expect this to be true or false. So we more or less test some arbitrarily chosen values. And for property testing, we kind of want to have a bit more of a principled approach where we actually model our tests to really test sort of certain ranges of the variables for which we expect a certain outcome. So yeah, to give an example, let me just uncomment these property tests here that we ignored in the previous lecture. So we're using here this Python hypothesis framework. And basically what we do here is that above the test, we use this annotation to specify what kind of ranges of values should be tested for each of the variables d and r. So for example, in this first test, so this is supposed to make sure somehow that whatever the redeemer is, if we unlock before the deadline, then it should fail. So what we do here is simply we tell a hypothesis that r should be an arbitrary integer, and d should also be an integer, but at least 1002. Okay, so here the idea is kind of that 1000 would be the deadline. So yeah, let's actually change here the waiting time to 1000. Yeah, so 1000 is the waiting time, and basically here we want to say that if somehow the deadline is larger than that, then we should always fail because we try to unlock before the deadline. Yeah, how exactly this hypothesis does it? I mean, in the end, it will also generate some values, but generate them a bit more systematically, and of course, for a lot more values than we would have in our unit test. So maybe let's still uncomment the rest and just run it so that we can see kind of that this works. So I still had kind of modification from the previous lecture. That's why the first test failed. Let me run it again. So now the 6 unit tests have passed, and you see that also the property test takes a bit longer because it tests a lot more values. But in the end, we see that it also passes. Right, so with this, we have maybe somewhat more of a certainty that actually this kind of deadline check works. And now for the next test, let's see what we have here. So yeah, this is of course kind of clear. We want the redeemer to be at most 0, so whatever positive redeemer we give, independent of what deadline is, we always want the thing to fail. So here we let it only give redeemers with minimum value 1, and we want the thing to fail. And then for the last test, basically you want to test that, okay, negative redeemers always succeed after the deadline. So we again choose redeemers that are at most 0, and we set the deadline somewhere between 0 and 998, because then it will basically, because we wait for 1000 slots, the deadline will be before, so the deadline requirement is fulfilled. And yeah, we want, in this case, we want the thing to pass. And so let me just run it again, because now we have all of them activated. And this really takes a while now to run because I assume that this hypothesis is really testing perhaps every single value for D between 0 and 998. And yeah, but now things have gone through and we see that all the tests have actually passed. Okay, so I hope that this can give you sort of an idea of how you can use property tests to not basically come up with individual cases, but to really test the properties of that the contract should have, and let this hypothesis like framework kind of handle the search for the parameters that might make it fail. If you want to learn more about how to use this hypothesis framework that has a lot more features, of course, than what we just had in this example here, then I also recommend you to have a look at the documentation and the guides they have on this website. And yeah, actually the next lecture, lecture 5 in the original Plutus Pioneer program, was again something about testing with the Lucid off-chain framework. Since we focus here on PyCardano, we will skip this, but of course you can go back to the Plutus program and watch it if you're interested in that. And then for the final lecture, we're actually gonna get to the homework. So see you for that.